In this video, I will explain you how to find potential at different points in a circuit. This is very, very important for your board examination. Now, let's take a simple circuit having two resistors connected across a battery. Now, what will happen? Positive charges from the positive side of the battery will have highest energy, because we know this charge is very near to the highest potential point. And what is the energy? We know that Q into V. Now this is highest potential terminal, right? This one is the lowest potential. Now it has got highest energy. With that energy, these charges will come here, and now it see a resistor connected in this way. Now that charge have to pass through the resistor. What will happen? The energy will decrease, because resistance is nothing but opposition for the flow of charges. Now against this opposition, it has to go to the other point. So some of the energy will be lost. Let's say the potential here is VA. So this is point A, this is point B, and this is point C. Clear? Now from VA, a small part is gone and it will reach here. So VB, we know that it is less than VA. Why? Energy is lost to pass through the resistor. Now from VB, it has to again pass through this resistance. So what will happen? Potential will again decrease, that is VC. So very important concept here is VA is the highest one, VB then VC. So across the current, across the direction of the current, potential will decrease. Or when current passes through a resistance, then potential will decrease, which means from where current is coming, that point will have highest potential, and to where the current is going, that point will have lowest potential. Okay. And another important concept is a positive charge has got higher energy here, that will go through the first resistor and do some work. Energy is lost. Now potential has decreased. Again it has to pass through a resistance. Potential will again decrease. Now from here, when the charge comes here, what will happen? This will goes to battery. Now inside the battery, again this will get charged. So from here it is charged, it will get energy. With that energy, it will do some work here. With the remaining energy, it will do some more work here. It will come back, again it will get energy. Now how it will get energy? When the charge move from negative to positive, right? Whenever the charges move from positive charge move from negative terminal of the battery to positive terminal of the battery, energy increases or potential increases. Clear? Now what will happen if it is moving from positive to negative? From positive to negative, when the charges are moving, potential decreases, V decreases. So that is very important concept. From negative to positive, when charge move, potential increases. Now from positive to negative, when charge move, potential decreases. Simple concept. You can remember this symbol diagram and understand the concept. Now along the direction of current, whenever current pass through a resistor, potential decreases. And what is this decrease in potential? We have learned that the equation V is equal to IR. Now when a current of I pass through a resistance R, V amount of potential will be decreased across. For example, here, let's say VA is the potential. Okay, let's say a current of 2 ampere is passing through this circuit. Now, what is the potential difference in between these two? We know that I into R. So, 2 into 2 is the potential difference. So, 4. Correct? Now, from VA, charges are moving, right? Positive charges are moving. Now, at this point, as I have told you, potential will be less, because from higher potential, it is coming to lower potential, or while passing through this, its energy loses, so potential loses. Now, it will be a lesser value. How much lesser? From VA, what is the lost value? 2 into 2, 4. Clear? Now, that is the value here. Now, from here, the charges are moving from negative to positive. Now, from negative to positive, when it is moving, potential increases. Now, let's say, what is the value of potential here? 10 volt. So that itself means that is the potential difference across the battery. Now that have to increase. So here what will be the value? VA minus 4 plus 10. Now we know that in a branch, this is a branch, right? One circuit, or these are connected in series. In series, current will be the same. So if it is 2 ampere here, here also it is 2 ampere, through the battery also 2 ampere, here also 2 ampere, here also 2 ampere, here also 2 ampere. Now we got potential at this point, right? How to get the potential at this point? We know that from this value, that is the value at here, a part is decreased. What is the part? Current into resistance through this. So what is the current? It's the same current. So 2 into 3, 6. That much will be decreased. So that is VA. What is minus 4 plus 10? Plus 6. Now plus 6, VA plus 6 is the point potential at here. Okay, from that 2 into 3 will be deducted. What is that? Minus 6. So VA plus 6 minus 6, that will be VA here itself. Now it is VA here and we have got a battery. Now it is moving from positive to negative. From positive to negative, potential decreases. And what is the decrease? It's the potential difference across the battery itself. Okay. Now this is VA, this will be VA minus 2. Clear? Here it is VA minus 2. Now 1 ohm resistor it is, current will be 2 itself. So what is the potential difference across this thing? 2 into I from IR equation. Okay, now here it will decrease. So VA minus 2, again 2 will decrease, then that will become VA minus 4. Now again we got one more resistance. While current pass through that, potential will again decrease. What will be the value? That is, current of 2 is going through this. So 2 into 2 will be potential difference across this thing. This is higher potential. So this 2 into 2 value, 2 ampere current, 2 ohm is the resistance. So 2 into 2 will be potential difference. That is 4. That will be decreasing from the highest part. That is VA minus 4. So VA minus 4 minus 4, that will be VA minus 8. Hope this concept is clear. Let me repeat it once again for you. 2, this is VA. Okay, from that 2 into 2, 4. That is VA minus 4 here. Now from negative to positive, it will increase. So VA minus 4 is here. It will increase by this much. VA minus 4 plus 10, that will be VA plus 6. Now 2 into 3, 6 have to decrease. Now from VA plus 6, 6 will go, then that will be VA. Now from positive to negative, potential will decrease. How much? By this value, VA minus 2. Now from VA minus 2, 1 into 2 will decrease, then that will be VA minus 4. Again resistance. Now from VA minus 4, 2 into 2 will decrease, that is 4. So VA minus 4 minus 4, VA minus 8. This is very important for your Kirchhoff law. So make a note of it. You can also expect questions like finding the potential difference in between two ends of a capacitor, and questions will be given in this way. So let's say you have a terminal where potential is 100 volt, then a capacitor, then comes a resistance, then a 0 volt point. So total potential difference is 100 volt. Now if the value of resistance is 100 ohm, what is the potential difference? And if the value of resistance is 10 ohm, what is the potential difference in between these two? We know that whenever resistance comes, when current pass through that, voltage will decrease. That is very important. When current pass through this, will the current be going from here to here? No, right? Because what is capacitor? Two plates, that is conductors, but in between you have dielectric, which means current cannot pass from here till here. This is an open circuit. When the current cannot pass from here till here, there won't be even current in this element of the circuit, that is through this resistance. So the current through the resistance will become 0. So whatever may be the value of this resistance, if it is 100 into 0, that is V is equal to I into R. So if the current is 0, whatever may be the value, 100, 10, 100, 1000, 10,000, whatever may be the value, the total potential difference will be 0. So there won't be any potential drop at here. The whole potential 100 volt will be dropping across the capacitor, irrespective of this value of this resistance. Okay, that is very important. And another important concept is, let's say in any part of the circuit, if you see elements like this, this is called as earthing, and always you have to make the potential of this point as 0. That is another important concept. Then another important concept is, let's say you have a circuit at home, okay, where a bulb is connected. Now, but the bulb is not working. The actual reason is there was a fuse. Now the fuse is broken here, so the current is not passing through this circuit. But to check, initial conclusion which we are going to make is there is an issue with the bulb. But actually that is not the issue. The circuit is open here. Now to check this, what we will do, we will keep a tester here, and keeping a tester is nothing but we are becoming a part of this circuit, and current will pass through from the higher potential through the tester through our body, and it will go to earth. It's basically earthing. So we will see a deflection, or we will see bulb glowing in the tester. So this circuit is fine. Now when we are keeping the tester at this point, basically it was supposed to give no value, but here in this case it will give value. Why? 100 volt, it will come and it will go through the bulb, and it can pass through to earth. So on both the terminal it will give a bulb glowing. What does it mean? It's not the problem with the bulb, it's the problem with the continuity of the circuit in this branch. Here something is broken. If at all, if there is an issue with the bulb, then current will not go in this way. So if both the terminal in the holder is giving a glow, that means that device has no issue. The issue is with the continuity of the circuit. You can check that. Clear? That's just an additional information. That's all. Thank you.